Hi, and welcome to this calculus video. In this video, we're going to use the mean value theorem for definite integrals to determine where a function is equal to its average value on a closed interval. It's important that you first have watched the video on finding average values of a function. So if you haven't yet done that, please do so, otherwise this one won't make sense. All right, let's look at what the mean value theorem for definite integrals is. The mean value theorem for definite integrals says, if f is continuous on a closed interval from a to b, then at some point, some x value c in that interval, this must be true. And we'll talk about what this means. So first of all, if you did watch the video on finding the average value of a function, you will see that this is equal to the average value of our function. So essentially, we're trying to see where this average value is equal to the function. So at what x value, and we'll call that x value c, is the function equal to its average value. Alright, so let's look at a picture of what this means. If we're going from a to b on a closed interval, we have this space, and in this case the integral represents the enclosure between the x-axis and the function, and that happens to be positive. If we calculate the average value, we're trying to figure out, again, the y value that makes this area exactly fit into that. So let's say this is our average value of our function. What we're looking for with the mean value theorem is what this c value is right here. And in order to do that, we have to take our function, our f of x, and set it equal to our average value for f. Alright, so in order to find the c value, first thing we need to do is find our average value for the function, and then we're going to set it equal to our function, and we're going to solve for that c value. So we're actually going to say what c value for our function is equal to our average value. Okay, so let's look at an example and see how this is actually worked out. Okay, here's our function. The first thing we want to do is figure out what the average value of that function is. So remember, your average value of your function is going to be 1 over b minus a times your integral from a to b of your function on that interval. So we're going to calculate this first, and then we're going to set it equal to our function. Alright, here we go. I'm going to rewrite my function as 9 times x to the negative 3. That makes it a little bit easier to find the integral. And when we evaluate that function, remember to be very careful when you're plugging things in. I'm going to rewrite this like this, just to make it a little bit easier to calculate. And then be careful when you simplify. I'm going to go ahead and simplify that up here so we can see everything on one screen. Again, if you're not using a calculator, which oftentimes you won't be able to, you're going to have to be really fastidious when you're solving these. So when you finally finish this, you should get 8/4, which is equal to 2. Now remember, this is not our answer, this is our average value for f. Okay, so we're going to take this average value and we're going to set it equal to f at some c value, and we're going to figure out what that c value is. So let's take our function, 9 over c cubed equals 2, and we want to know what our c value has to be. So I'll do this in a different color so it's a little bit easier to see. Using cross products, we can do that here. We can say that 9 halves is going to equal c cubed, and if we take the cubed root of each side, the cubed root of 9 halves equals our c value. In other words, when x equals the cubed root of 4.5 or 9 halves, our function is equal to its average value on the closed interval from 1 to 3. And let's look at a quick picture of that so we can graphically see what's happening. So right here you can see that I have created a graph of our function, which is in red, the horizontal line that represents the average value of our function, and then a vertical line which happens at the point of intersection. So you can see that 1.651 is an approximation for 9/2 to the 1/3 power, and that is where our average value of our function is exactly equal to our function. So at that x value, or that c value, is where those two things happen to intersect. I hope this explanation helped you understand how the mean value theorem for definite integrals works a little bit better. Make sure you ask questions and review this video if you need any help.